We're going to continue our work in looking at graphs of functions and describing key attributes. In this video, we'll talk about determining the intervals in which a function increases and decreases. And we're going to be writing all of our answers in interval notation. Now, an increasing function, what does that mean? Well, it means that the y values, or the function values, or the y values are increasing as the inputs or x values are increasing. So in other words, as the x values get larger, as we go left to right on a graph, the y values are increasing, so the graph is getting higher, right? So you can think of it as going uphill on a graph. Okay? And then a decreasing behavior, now the function values or your y coordinates are decreasing, they're getting smaller as the inputs increase, as x gets larger. So in a graph, you would be looking at a function where the function looks like it's going downhill, right? Okay. And one of the things I want to remind you of is when we are talking about describing intervals of increasing and decreasing behavior, that we are going to describe these intervals in terms of x. So even though we're going to be looking at our output values, at our y values going up or down, we describe the intervals themselves in terms of x. So our intervals will be looking at the x values. Okay, will be described with the x values. And also another thing I want to note is that when we're describing intervals of increase and decrease, we will always use parentheses. You won't find us using brackets when we're describing increasing and decreasing behavior. We did use the brackets as needed when we describe domain and range of a function, but in our intervals of increase and decrease, you will be using parentheses. So let's take a look at a few of these examples. So here's our first example, which you will recognize as being an upward parabola. Again, on the endpoints, I put the little arrows because those are implied. And let's look at where the parabola increases and decreases. Now, with a parabola, it's good to note where the vertex is. Okay, so our vertex in this parabola is right here, and that's our lowest point, isn't it? So on the left-hand side of this parabola, you can see this little leg here on the left, okay? So our x values are going to increase as we go left to right, and as we go left to right and we look at this parabola, you will notice that in this little branch of the parabola, our y values are going down. So this is decreasing behavior, isn't it? And so our decreasing behavior is to the left of this vertex, and again the vertex is at 0, -1, right? So x equals 0. So that tells me that from -infinity for my x to 0, that's where we have this decreasing behavior. So notice again that I'm describing in terms of x. I did not use the -1 that's part of the vertex. I used the 0 that was part of the vertex. Okay, so on the right hand side here of the vertex, now our parabola is going uphill, right? So our y values are increasing, and that's going to be our interval of increase, which will then start at that 0 from the vertex and go towards infinity. Okay, let's take a look at the next example. Now we have a parabola that is pointing downwards, isn't it? So in this parabola, our vertex is our highest point. Vertex is once again at 0, -1, okay? But this time around, our leftmost branch here is actually our increasing branch this time. Okay, so as our x goes from -infinity to that 0 of the vertex, our parabola increases, right? And then on the right hand side of the vertex, the y values go down, right? So we have a downhill branch there, and so that is the interval where our parabola is decreasing. So again, we're using the x value of the vertex, not that y value. Okay, let's take a look at next example. Here again, we've got some relative maximum and minimum points, right? So we have this guy right here is like a highest point, at 0, 0, right? We have a relative maximum there. And then this point right here, which is at 2, and it looks like, oh, about 1.5, -1.5, right? But at 2, and let's say it's -1.5, just to give us an idea, that's a relative minimum point, a relative lowest point there, right? So we're going to look at the different pieces of this particular function. And so we've got some uphill behavior or increasing behavior happening here on the left-hand side of this relative maximum, okay? And we're going to describe that again in terms of x, so it'll be -infinity to 0. But that's not the only place where our function is increasing. It is also increasing here, isn't it? It's also increasing on this piece. And so we're going to write union, and then that starts at the x-coordinate of 2 and goes to infinity. So again, reminding you that we're going to be describing our increase and decrease intervals in terms of the x. And then in between, we've got this little piece where the function decreases, and that happens from x equals 0 to x equals 2. Okay, so there's our decreasing behavior. Looking at the next problem, we have this asymptote, don't we? So we talked about asymptotes in a previous video. On the left-hand side of the asymptote, here we have what kind of behavior? Can you tell that it is a decreasing behavior? Okay, and it happens on the left of this x equals 2 asymptote. By the way, that's the equation of the asymptote because we have a vertical line there at x equal to 2. And so we've got this decreasing behavior on the left side of the asymptote. So that's from x equal to -infinity to 2, right? So that's that piece there, that branch. Then what happens on the right side of the asymptote? Well, guess what? I mean, the function is going downhill there as well. It is decreasing there as well, isn't it? On the left side of the asymptote, as your x's are getting bigger and bigger, going more towards the right, your y values are getting smaller and getting closer to that other asymptote of 0, right? Of y equals 0. We'll talk about that in another video, but definitely decreasing. So we're going to put that interval here as well in the decreasing, and notice there that there's no place where this function increases. So we can say does not exist. DNE does not exist. So this function never increases. It is always decreasing. Isn't that interesting? Okay, let's take a look at some more examples. In this next example, now we have here half of a parabola, but actually you're also going to learn that in this class, this is the graph of a radical function, okay, a square root. But anyway, you can see that this graph is always increasing, isn't it? It's as our x's get bigger, going towards the right, our y values are going up. So we have an always increasing function, and that starts at the domain value of 1. So we're going to write 1 to infinity for where the function increases, never decreases. So that's a DNE, does not exist. So it does not decrease. It is always increasing. Now I want to just do a quick note here. It depends on the textbook that you are using in your course. You will sometimes see that with these functions where the domain starts at that 1, that some authors like to write the increasing interval includes the 1. So they use the bracket, okay? There's actually quite the controversy between the two, and it really depends on the textbook that you're using whether you will see the bracket used for this example or the parentheses. Now in our MOER learning system in this class, we will be using the parentheses. So that's just a note for you in case your particular textbook uses the bracket, okay? Now let's go to the next one, and here we have so this one's got quite a lot happening here, doesn't it? So first of all, let's go look for those relative maximum and minimum points, because that's where the graph will be turning, isn't it? So we've got one here, There's one there that's a local minimum, right? It's like a lowest point in this little neighborhood of the graph. Then we've got a local maximum here, right? And then we have a local minimum down here. All right, so you see those 3 points are very key in this graph, aren't they? That's where our graph changes from increase, decrease, or decrease to increase, right? So now we've got that the graph first decreases. It goes downhill until it reaches that x equals -1. So from negative infinity to -1, again, remembering that we are using the x value to describe that interval, we have a decreasing function there, right? And then kind of turns at that little local minimum and it goes uphill. Let's look at that uphill for this little piece right here. From what is that, -1x to 0. All right, so we're going uphill for just that little bit. Okay, and then what happens? Well, the function decreases. So now it's going downhill again. And that happens from 0 to 3. And again, remember, we're going to describe this in terms of x's, and that little minimum there is at -11, isn't it? But remember, we're not using the -11, not the y value, we use the x value. So from 0 to 3. And then finally, our graph turns around again and goes uphill for the remainder of the x values. So from 3 to infinity, we have an increasing piece there. Okay, I hope that helps.